All right, in this video, I'm going to go over factoring expressions with fractions for exponents or negative exponents or negative fractions for exponents. I'll just go straight to the negative fraction. All right. Now, another way to put this, instead of that long, complicated name, I just want to point out first, I just feel like this is just advanced greatest common factor. That really is all we're going to do here. Except there's another way to do it, because I feel like this greatest common factor thing can be a little bit much for somebody to handle, even me. And I prefer to think of something else that maybe I can wrap my head around a little better than taking the greatest common factor of something like this. So what they want us to do is recognize that x plus 2 and x plus 2, these are the same, right? So we can treat that like all one number, like it's all one variable, like almost like 3xy to the negative 1/3 plus 4y to the 2/3. And we can factor that out. And when we factor something out, we're dividing it by both all the terms in any polynomial, right? So we can factor out y to the negative 1/3. And if we divide by y to the negative 1/3, we divide this part, it's just going to cancel out. So it's just 3x left there, right? But over here, if we divide by y to the negative 1/3, we're going to get something awesome is going to happen here. Because these cancel out, they actually kind of like change the sign here and they add it together. That's what you do when you divide exponents, you know. So negative 1/3 plus 1/3 is actually y to the 0, and that's why it cancels out, quote, cancels out, because anything to the power of 0 is just 1. So what happens here is we have 2/3 plus 1/3, and we just end up with y to the 1. Whoa. But instead of saying y, we're just going to put what we originally had here, x plus 2. I just used y just to help us understand what we're doing there. And I want to use brackets because this is being distributed to this 3x and to this 4 times x plus 2 over here, right? And we factored it out. See, now this we can actually do something with, right? We can treat this, I use brackets because it doesn't make sense to have parentheses right next to other parentheses. But if I get rid of these parentheses and distribute that 4 there, we have this 3x still, and we have 4 times x, and the 4 times 2. And that is all being multiplied by x plus 2 to the negative 1/3. And we can simplify this down a little more. 3 plus 4 is 7. And there's your answer. That's all we did. It's kind of just crazy greatest common factor thing. Now, there is another way to do this. Usually when I factor things out, I like to, distribute them and try and prove that it's the real answer. But this is kind of a special case where, you got to notice you just kind of go backwards and it's all the same, right? But another way to check it is to find the same answer in a different way. So I'm going to leave that answer written out there and see if I can get that answer again in a different way. Now, that was kind of that greatest common factor thing can be difficult to wrap your head around. So instead of thinking first off greatest common factor, whenever I look at a problem like this and I see a negative exponent, I think, oh, there's that reciprocal rule where if you put the number with the negative exponent, on the other half of the fraction of a fraction, it becomes a positive exponent, right? X to the negative 1 equals 1 over x, and 1 over x to the negative 1 equals x. It's just a rule. It's called the reciprocal rule. I use it all the time. And you're like, well, how does this help me, Joe? Well, instead of thinking greatest common factor, now I'm thinking, you know what? I need a common denominator so that I can add these two fractions together. That's my problem right now. What's the common denominator? Well, x plus 2 to the 1/3. How do we do that? We multiply the number that we need to change the denominator of by 1. But it can't be just 1 over 1. It's got to be this, x plus 2 to the 1/3 under x plus 2 to the 1/3, because anything divided by itself is 1. So we're just multiplying this by 1. So if anything multiplied by 1 is going to be the same thing, it's just going to look a little different because we want it to have a common denominator so I can add the fractions together. So let's do this. X plus 2 to the 2/3 times x plus 2 to the 1/3. Well, we just add those exponents together, right? Because this is the same. So it's just 3 over 3, which is just 1. So let's just move this down to the next step here. Not equals. So 4 times x plus 2 to the 1 power, which is just x plus 2, over x plus 2 to the 1/3. Okay. So now we can add these fractions together. And our answer, the denominator, isn't going to change at all. And we're just adding these two numerators together. And guess what? We can distribute this first too. And we'll get 4x plus 8. And we can say 3x plus 4x is 7x plus 8. And thanks to our reciprocal rule, we know we can move this up to the top and get x plus 2 to the negative 1/3. And those are the same exact answer reached in completely different ways. So if you struggle with the whole greatest common factor thing, you can use your knowledge about finding a common denominator to add fractions together. If you struggle with diffractions, you can use the greatest common factor. No problem.